Hello everyone, today we're going to prove that the sum of the first n natural numbers is going to be equal to n times n plus 1 divided by 2 for n greater than or equal to 1. So how can we do it? Well, we can do it by mathematical induction. This is a way to prove things in two steps. So the first step is to prove this formula for a certain value of n. For example, n equals 1. Why n equals 1? Because we want to prove it for n greater than or equal to 1. So it's useful to prove it for n equals 1. And this is called the basis step. So obviously the sum of all natural numbers from 1 to 1 is just 1. And this equals 1, because n equals 1, times 1 plus 1 all divided by 2. So this equals 1 times 2 divided by 2, and this equals 1. So we have just proved that 1 equals 1. So this formula clearly works for n equals 1. But we have to prove that this formula works for every integer n greater than or equal to 1. So how can we do it? Here it comes the second step of the mathematical induction. So we have to assume that this formula works for n equals k, where k is any natural number. Then we have to prove that this actually works for every number k plus 1. And I'll show you why in a moment. So let's assume that this works for n equals k. So the formula is going to be 1 plus 2 plus ... plus k equals k times k plus 1 all divided by 2. And we assume that this works for n equals k. Now we have to do the same thing for k plus 1, and we have to check whether it works. So if 1 plus 2 plus ... plus k is the sum of the first k natural numbers, what is the sum of the first k plus 1 natural numbers? Well, this is obviously 1 plus 2 plus ... plus k plus k plus 1, because k plus 1 is the number after k, because it's k plus 1. So what is this equal to? Well, as you can see, we have a formula for the first part, because we assume that this worked. So we can replace 1 plus 2 plus ... plus k with k times k plus 1 divided by 2. So let's do it. This equals k times k plus 1 all divided by 2 plus k plus 1. So this equals 2 and k times k plus 1 plus 2 times k plus 1. We are just manipulating this expression algebraically to actually get our proof. Now we can factor out k plus 1, so this equals k plus 1 times k plus 2 all divided by 2. Okay, so this is what we got. But now we can even do another step. So this equals, as you can see, to k plus 1 times k plus 1 plus 1 all divided by 2. As you can see, we have a k plus 1 here and here. But this is just this formula for k plus 1 instead of k. So we've proven that if we assume that it works for n equals k, so for every natural number k, it is going to work for k plus 1. But we prove that for n equals 1 this works, because we get that 1 equals 1 using this formula. But now if it works for n equals 1, and we know that if it works for every natural number k, it is going to work for k plus 1, it works for n equals 1. So it is going to work for 1 plus 1. that equals 2. So this formula also works for n equals 2. But if it works for 2, it is going to work for 2 plus 1, that equals 3. But if it works for n equals 3, it is going to work for n equals 3 plus 1, that equals 4, and so on. So this is the induction proof. So we actually proved that this formula works for every n greater than or equal to 1. If you enjoyed this video, leave a thumbs up, share it with your friends. Until next time, bye!